Have you ever stopped to think about how your thoughts literally, physically change the shape of your brain? Well, you're in the exact right place. In this explainer, we're going to bridge the gap between the microscopic, hard science of brain rewiring and the practical behavioral tools of neuro-linguistic programming, or NLP.
Here's our roadmap. We're going to hit the gateways of memory and microclusters, dive into the neurology of NLP, hack some submodalities, and finish up by anchoring new neural pathways. Let's get right into it.
So, part 1, the gateways of memory. We really need to understand the actual physical structures where learning happens.
Now, can you actually physically shrink your bad memories? I know, it sounds totally like science fiction, doesn't it? But we're not just talking about, shifting your mindset in some woo-woo abstract way. We're going to look at how you can manipulate the literal microscopic gateways in your own brain to physically shrink down those bad memories.
Neurons that fire together, wire together. You've probably heard Donald Hebb's famous rule, right? It perfectly nails the concept of spike timing-dependent plasticity. Put simply, when brain cells fire together in a highly coordinated way, their physical connection gets beefed up. We used to just guess that this happened, but now, thanks to some insanely advanced microscopy, we can literally watch it happen in real time. Okay, check out these microscopic, kind of lollipop-shaped structures. These are your dendritic spines. They're unbelievably tiny. We're talking minimal functional units of memory here. But this is exactly where learning takes physical form. Every single time you learn something new, or, hey, even when you're just obsessively dwelling on a past memory, you're firing electrical signals directly into these tiny gateways on your neurons.
Moving to part 2, rewiring your microclusters. Let's look at the actual biological mechanics behind changing these synapses.
So here's the biological showdown between making a memory stronger versus making it weaker. On the left, we've got long-term potentiation, or LTP. This is what strengthens a memory. The neck of that spine literally shrinks down. It's almost like pinching off a water balloon, which traps calcium and AMPA receptors inside to build this rock-solid connection. On the flip side, you have long-term depression, or LTD. This weakens the connection through uncoordinated activity. The spine loses those receptors, the calcium drops, and the memory essentially just fades out.
And here is where the science gets wildly specific, 5.7 microns. To put that into perspective, that is roughly 1/10 the width of a single human hair. Basically, if you activate two dendritic spines clustered closer than 5.7 microns apart, they actually team up cooperatively to trigger LTP and build a lasting memory. But a single, isolated signal, it might do absolutely nothing. The takeaway here is that your brain strongly favors clustered, coordinated signals.
Which leads us to what is, honestly, the ultimate neurohack. Researchers discovered that if a connection is currently weakening, undergoing that long-term depression we just talked about, introducing a new clustered signal nearby can completely wipe out that depression and actively convert it into long-term potentiation. Think about that for a second. You can biologically overwrite a fading weak signal just by introducing a strong, clustered one right next door.
All right, part 3, the neurology of NLP. This is where we bridge all this brain science with behavioral programming.
This is exactly where we connect the biological hardware to the behavioral software. Say you want to intentionally weaken a bad habit or a rough memory. NLP uses what are called submodality shifts to disconnect the emotion and intentionally trigger that long-term depression. But when you want to physically shrink those spine necks to lock in something like confidence, NLP uses state control and self-anchoring to trigger LTP. You are quite literally using your behavior to drive your biology.
So here are some of the most practical NLP tools you can use to manage your internal state. Let's look at the spinning feelings technique as an example. When you visually map out a heavy, visceral, negative emotion and mentally spin it backward, you're not just, thinking happy thoughts. Oh no. You are actively disrupting the coordinated timing of your neurons. You're effectively starving that bad memory of the local calcium buildup it absolutely needs to survive.
Let's move to part 4, hacking your submodalities, so we can finally stop that exhausting loop of negative past memories.
In the world of NLP, every memory has foundational building blocks called submodalities. Basically, the sensory qualities of your mental movies. Is the memory bright or is it dim? Is it loud or quiet? By consciously, intentionally altering these visual properties in your mind's eye, you're directly altering the electrical input feeding into those dendritic spines. You're essentially forcing long-term depression to kick in, which completely strips the memory of its emotional power.
I want you to try this exercise. Next time a bad memory hits, just freeze frame it like a movie.
See, most of us get stuck because we stay associated, meaning we relive the event through our own eyes. When you do that, you're dumping a massive, highly coordinated signal straight into your anxiety networks. So instead, step out of your body, become dissociated. View yourself in that memory from a distance, almost like you're watching a total stranger on a cinema screen. Just that simple act of stepping back instantly uncoordinates the neural timing, triggering that glorious long-term depression for the negative event.
And that brings us to our final section, Part 5, Anchoring New Neural Pathways. Let's see how we use physical actions to lock in empowering states.
Okay, remember Donald Hebb's rule from earlier? Neurons that fire together, wire together. Well, NLP state control utilizes physical triggers, like clenching your fist, to quickly recall powerful emotional states. By intentionally linking a physical touch to a strong feeling of, say, calmness or confidence, we are literally forcing those specific neurons to fire simultaneously. We're totally exploiting that 5.7 micron proximity rule. We're clustering the physical sensory input of the fist with the emotional input of confidence. This triggers rapid spine neck shrinkage, traps the calcium, and solidifies a brand new, incredibly efficient neural pathway.
In fact, I highly encourage you to physically practice establishing this spatial anchor with me right now. First, wait until you feel fully present, focused, and totally safe. Got it? Okay, now press your thumb and forefinger together tightly for about 5 seconds. By doing this, you are intentionally sending a clustered sensory signal straight into your neocortex. So the next time your mind starts drifting back to a bad past memory, just press those fingers together again to snap right back to the present. You've physically wired these neurons together so you can override the negative loop. So what's the big takeaway from all of this? It's that your brain's microscopic structures are absolutely not static. Right down to the literal thickness of their necks, they are highly malleable. By harnessing the targeted behaviors of neurolinguistic programming, you aren't just changing your mind, you are quite literally physically reshaping the very architecture of your brain. You are the architect here. So, what mental movie are you going to rewrite today?